G'day folks, it's DIY Guy 123 here bringing you another do-it-yourself video. Today we've got a ham radio set up and I was troubleshooting a problem. I'll talk to you about how I used an oscilloscope to figure it out. Basically, we've got a 12-volt power supply powering a Xeigu G90 HF radio, and the output of the radio, this built-in speaker is acceptable, but I wanted something a bit better, and I happen to have this much larger Yeasu speaker. The quality is a bit better. It's got some built-in filtering, so I thought, hey, let's get this going. So when I hooked the audio up from the HF radio output to the back of the speaker, nothing happened. That's because the audio output of the HF radio is not strong enough to power a passive speaker. And this speaker right here did not come with any powered electronics. It was a passive device with filters and a speaker, but no power amplifier. So I bought this power amplifier off Temu for $3 or $4 and installed it, and it worked beautifully for a week. And then after a week, I started hearing crackling and sputtering and hissing, and then all of a sudden, no sound. Well, my assumption was that it was the power amplifier that went bad since it was inexpensive and who knows what the quality was. So I thought that was the problem, but before I swapped it out, I thought I'd better just do some diagnostics to check here. First things first, let's verify that we have DC voltage powering our speaker. And I know that we do, but I'll just show you. I'm measuring it at the power supply here, and we have 13.8 volts, and that's perfect. And I know that that voltage is connected all the way through to the power amplifier. So the next thing is, I've got this old oscilloscope. This oscilloscope was made in 1977, and believe it or not, it came with the manual, and somebody gave it to me, so that's pretty cool. So I've got two probes. They're ×10 probe, which means they reduce the signal by a factor of 10. So you have to remember that when you're looking at your vertical volts per division value, you have to multiply that by 10 to get the true voltage. Now, I took the probe number 1 and put it on the input. So this is the output of the radio, the input to the powered speaker, and that's what we're seeing right here. So I've got the volts per division set at 0.01 times 10, which is 0.1. The peaks of this are from the bottom of the screen, 1, 2, 3, almost 4 divisions up. So it is 0.4 volts from peak to peak. So that meant that the radio wasn't bad. Probe number 2 is looking at the output of the power amplifier. So I'm going to move probe 1 way up here out of the way, and I'll move down probe 2, the output of the power amplifier. Now it's hard to see on the screen, but this is 0.01 volts per division. This is 0.1. So I've got this as a 10 times greater voltage per division on probe number 2 on purpose. Now when I turn the volume up on the speaker itself, if I look at that bottom straight line, probe 2, I see the voltage growing. I'm turning the volume up and then I'll turn it back down and I'll turn the volume up. So what does that tell us? That tells us the power amplifier is working. It's taking this signal right here and amplifying it by setting this volume at the 3/4 mark. And since this is 4 divisions for probe 2, the output of the power amp, and the input of the power amp is 4 divisions, and there's a factor of 10 here, that means my amplifier is multiplying by a factor of 10. So the amplifier is working. So why isn't there any sound coming out of this speaker? I unplugged the power from the speaker, I waited for the voltage to dissipate on the power amplifier, and I put my ohm meter directly across those leads for the speaker. Now this is an 8 ohm 3-watt speaker. If the speaker was just disconnected from the power amp, it should be 8 ohms. But since it's connected to something else, it should be 8 ohms or less. And that's because the power amp would be in parallel with the speaker. And let's unplug the power from this speaker so we don't damage our own meter. I'm actually going to hold the camera in my mouth. I'm going to measure the resistance between the 2 speaker terminals and check the meter, and it should be 8 ohms or less. So let's see what it says. The impedance of that speaker is open circuit. Not great, should be 8 ohms. That means the speaker itself is blown. I don't even have to disconnect these wires to prove that that's the case. So now that we've proven the power amplifier is amplifying the input signal by 10 times and sending it to the speaker, but the speaker's not making any sound and there's infinite impedance at the speaker, open circuit, that suggests to me that everything is working. So let's bypass that speaker. I've got this high quality Klipsch floor standing speaker, which is way overkill. Let's plug in that Klipsch speaker and see what we get. I'm gonna turn this volume up right here. It proves that the speaker itself was faulty. I need to get a new speaker this size to install in there, and then I should be good to go. Good luck with your do-it-yourself projects. If you like my videos, please subscribe.